Finish off section 5.3, we're going to talk about differential equations. So what is a differential equation? Well, one example of a differential equation is something that looks like this. dy dx is written is given to be some function x. The question is, what is y? And so really what we're doing when we're finding antiderivatives, we really are solving these differential equations. So for example, if we were to write out, so a formula that we know from before, the integral of x squared dx is equal to x cubed over 3 plus a constant. And so really what this is saying here is, to translate this into differential equations form, dy dx is equal to x squared. And so the solution of this, so dy dx is a function here of x. The solution of our differential equation is y is equal to x cubed over 3 plus a constant. And for different constants, this will give us different solutions here. Sometimes to further tack on things for our differential equations, we will have a so-called initial condition. And so an initial condition is something of the form that says y of x naught is equal to y naught, where x naught and y naught are particular fixed values. And so what this initial condition does is that it tells you, it kind of tells you what value of plus c, what value of c to give here. So there's there's infinitely many solutions here, but once you use this initial condition, you get exactly one solution. So let's just see how this works. Let's say that we have dy dx is equal to 4x to the 7th. So we're trying to solve this. So we know that the integral, the indefinite integral of 4x to the 7th dx is 4 times 1/8 x to the 8th plus c. So that is 1/2 x to the 8th plus c. So however, now I have to tell you so this is our general solution. So I didn't tell you here, I probably should have at the start, tell you that the initial condition is y of 0 equals 4. So this says that when x is equal to 0, y is equal to 4. So how do we find what c is? Well, y needs to equal 4 when x needs to equal 0. So what do we have here? 4 is equal to c. So our particular solution is y is equal to 1/2 x to the 8th plus 4. So we have a dy dx is this function. We find the general solution. We use our initial value in order to figure out what should the constant be to find our particular solution. Let's do another example. Let's do one involving a trig function. So dy dt is equal to sine t, and y of 0 is equal to 2. And it's very common in these problems that I give you y of 0. That's the most common way that these problems look. So to find the general solution, we integrate sine t dt, and we get minus cosine t plus c. Realize here the derivative of minus cosine t is sine t, so that checks out. So y is equal to minus cosine t plus c. When t is 0, y needs to be 2. So 2 is equal to minus 1 plus c. So c is equal to 3. So our general solution here is y is minus cosine t plus 3. So we take the derivative of this, we get sine t. And if we plug in 0, we get 2. So that checks out. One more example of this, something to do an applied problem. So a car has velocity 24 meters per second. It it starts to slow down at time t is equal to 0 with acceleration a is equal to minus 6 meters per second squared. So what this is basically saying here is that we have a of t, so this is true for t is greater than or equal to 0. So a of t is equal to minus 6. Now what's the relationship between v and a? So v prime of t is equal to a of t, which another way of writing that is that v of t is equal to the integral of a of t. So if we can crunch this out, the integral of minus 6 dt is minus 6t plus c. So v of t is minus 6t plus c, but this 24 meters per second, that was when t is equal to 0. So v of 0 is 24, is minus 6 times 0 plus c. So 24 is equal to c. So now we have an expression for v of t. So v of t is minus 6t plus c. So we got an expression for v of t. We can kick this one step further down the road. So no pun intended there. So position. So let's say s of t is our position function. Now s prime of t is velocity. So how to go from velocity to position? Position is the integral of velocity. So if we want to integrate, so oops, my apologies on that previous slide. I forgot to plug in that 24. I'm sorry about that. Now let's go ahead and integrate minus 6t plus 24. And so we end up with the integral of minus 6t is minus 3t squared plus 24t plus c1. I'm calling this c1 to differentiate, no pun intended, from this c here. I want those to be different. And so if we suppose that s of 0 is equal to 0, we just kind of say that the position of the car when t is equal to 0 is 0. S of 0 is minus 3 times 0 squared plus 24 times 0 plus c1. So this says c1 is equal to 0. So overall, our position function is minus 3t squared plus 24t plus 0. So this will allow us to, we can really reverse engineer a lot of things by doing integration. So this section is intro to indefinite integration. Let me just wrap things up with a couple of big picture comments. Big picture comment number one is that anti-differentiation is generally a more difficult process than differentiation. It's usually easier to take derivatives than it is to find integrals. In fact, there are some problems, there are some functions that in some sense, I mean we have to be more precise here, but in some sense there just aren't antiderivatives of these functions in elementary terms. In other words, there are some problems in which it's basically impossible to do. So you won't be asked to do those. Another thing to comment on is that this little wrap-up thing about differential equations in a set of videos. So this is the so-called Calculus 4 course here at Rutgers. So if you keep on taking math classes, you'll go through Calc 1, 151. You'll go through Calc 2, 152. In 251, that's multivariable calculus. And then the next course you're likely to take in the sequence after multivariable calculus is either 244 or 252, which are differential equations courses. So here's your first differential equations that you've seen, and there's an entire course, and 2 different courses depending on whether you're engineering or a math major. That's the big split there. There's 2 separate courses that you can take in this down the road.